Hello guys, today I would like to show one distinct thing about the integral on the left side of the screen, which is common known, especially from the second course of calculus. It is very well-known integral, and when evaluating it, we use the Lebeg integral. Lebeg integral is a very cool thing and a very useful thing, but today we would like to try to get it, to evaluate it without Lebeg integral, only by using Riemann integral and Riemann iterated integral. It is integral from integral without formula of changing the variables. So using the Lebeg integral, you just multiply it by itself, but with the y-axis, use the changing variables formula, and get the determinant of the Jacobi matrix, Jacobian, which will move us to something like this integral, and this integral is trivial on the right side, right? It's trivial to calculate, which means our goal is, by multiplying by some other integrals, to get something very close to this thing. And let's try to do this without Lebeg integral. So if you would like to move x a pair, we can try to do something like this. It's a very interesting trick. Move it right like e from xy squared negative xy squared dxy, and now write it as x times dy. We will get those x, and after multiplying these integrals, it will be moved like there, like we have wanted. But we don't know what happens later, but let's hope everything will be fine. We'll write integral sign there, like I equals, and changing the variables. Yes, it is. Now let's multiply them by each other, just like this. So, what is that? Does integral of integrals converge? Does it? Yes, it does, because seriously, you just look there. It is obviously that it converges, because you can say this thing is okay. Let's try to explain. This function can be limited from the upper bound for every x and for every y by the integratable function by xy, meaning dx dy. Like exponents are integratable, it's trivial. I mean, this integral is integratable, this function is integratable, and we can set the upper bound like these two integrals multiplied by each other. It's obvious that this function is integratable. It means this function is integratable too. I would like to write the whole proof, just it works. Now moving this x there, multiply and divide by 1 plus y squared means this integral, assuming that y is constant. Just like this. Almost forgot to write 2 in the denominator. Sorry about that. But now we just have to integrate this beautiful exponent. Let's write it like u squared. No, nobody, even u, no, just u. Let's move all the constant out of the integral, I mean du integral. Just like that, and now this integral is trivial, this 1. And now this is just, our tangent, and this is, no, it's trivial. Pi over 2 divided by 2 is pi over 4. But it was our integral squared. What is our integral? The square of pi over 2. Yes, it is. We all know it. Also, I've said that this is obviously convergence. Uniformly converges from 0 up to infinity. X lies into. But this isn't obvious, right? Maybe. Let's say that this thing derivative by dx is 0, means it implies something like, so what is it? Is it minimum, maximum maybe? But note that if x equals 0, it is 0. It is 0. It's minimum. If it is infinity, it is minimum too, because of the exponent now, not of the x, because the exponent means it is maximum. It means we can write this in equation, like setting x those there. Yes, it is a very strange thing, but if we prove that this convergence, we will prove that it's convergence anyway.